శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ 2008 లో స్థాపించిన కళాశాలలో MBA, NAC A గ్రేడ్ మరియు ISO సర్టిఫికేషన్ సాధించిన మొట్టమొదటి కళాశాల శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ త్వరలో అటానమస్ కాబోతోంది.
2014లో ISO గుర్తింపు, 2015లో రాష్ట్ర ప్రభుత్వంచే A గ్రేడ్, 2016లో NAC A గ్రేడ్, ఇప్పుడు NBA సాధించిన సంస్థ శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ.
Good morning students, I am Harsha, assistant professor from the department of EEE. I am going to teach the subject for 3rd BTech first sem students, and the subject name is renewable energy sources. Let us start the basic introduction about renewable energy sources. Good morning to all. In the previous session we have discussed about solar thermal energy. In this session we are going to learn about solar flat plate collectors and solar concentric collectors. Let us see initially what are the uses of solar energy. So by using solar energy you can heat your swimming pool with solar energy, you can heat your water, you can charge your battery, and you can take power from your for your home. You can take the power for your home with solar energy. You can use it for cooking, you can use it this solar energy for indoor lighting, and the solar energy can use it for outdoor lighting also. So these are the main uses of the solar energy. In our daily life we are using all these things by using solar energy. Let us go for the next slide. So what are the solar technologies? So you have daylighting, passive solar heating, and active solar heating, and concentric solar thermal, and photovoltaic. So you can see the pictures of daylighting, and passive solar heating, and active solar heating, and concentric solar thermal, and photovoltaic PV. So these are the solar technologies used in solar thermal energy. So let us see for daylighting. What about daylighting? In daylighting, by using daylighting you can charge your photovoltaic cell, and you can use it for your home and for your office purpose also. And what about active solar heating? You can see the pictures of your active solar heating. There will be a flat plate collector here. You can see this flat plate collector, and you can see the evacuated tube collector also. So by using this flat plate collector you can charge your solar panel. Okay, so inside solar panel there will be a photovoltaic cell. This photovoltaic cell will be charged. So by using this solar heating, so you can see this flat plate collector here. Initially from the flat plate collector it will be there will be a fluid. In the previous session I have told you there will be a molten salt. This molten salt will be heated, and this heated fluid will be stored into a storage tank. So this is the antifreeze fluid in the collected loop only, and this is a pump, and there will be hot water to house and the cold water to supply. So you can heat your water by using this solar heating. So there are two ways of heating your water. So one is you can send a cold water into this solar panel, and whenever the sun hits this solar panel, your water gets heated and it will be sent to your storage tank, and you can use your hot water. Okay, by like this you can heat your water by using this water. So this is about active solar heating. So here you can see there is a flat plate collector and evacuated tube collector. These under the solar panel there will be tubes. So under these tubes these water will be get heated, and cold water will be sent inside, and you can take the output as hot water. So input will be cold water and output will be hot water. So by using this solar charger, I mean to say solar panel. So your water gets heated and you can use this active solar heating. Let us see the next slide. So there will be concentric solar heating also. You can see this concentric solar heating. So there will be a solar mirror. By using this solar mirror, so there will be an tubelet of molten salt. There will be under the solar panel, under the solar mirror, there will be an molten salt. This molten salt will be get heated under the solar mirror, and this molten salt fluid will send into the hot storage tank. From the hot storage tank, it will be send it to the steam generator. From through steam generator, it produces the steam, and this steam will hit the turbine, and your electrical energy will be generated by using concentrating solar power. So you can see the power tower, the image of the power tower. The one side of power tower, there will be power tower. So let us see how power tower works. So whenever the sun hits this solar mirror, so this solar mirror will reflect the receiver. Through receiver, so this rays will be received, and from the cold storage tank, the water will be sent into the tower, and the water will be get heated, and it will be sent into the hot salt storage tank. So the cold water will be sent through a salt, which is nothing but a molten salt. So this molten salt will be heated and send it through the hot salt storage tank. So from the hot salt storage tank, it will be sent to the steam generator. So this steam generator will generate the steam, and this steam will be sent through the tubelets, and from the tubelets this steam will travel and hits the turbine generator. So this turbine will rotate and electrical energy will be generated. So the mechanical energy will be converted into electrical energy. Let me repeat it again. So whenever the sun hits these solar mirrors, through these solar mirrors will reflect on the receiver. This receiver will receive these solar rays, and this from the solar rays, this receiver receives, and the cold water which is with salt will be heated, and it will be entered into the hot salt storage tank. From the hot salt storage tank, it will be entered into the steam will into the steam generator. So from the steam generator, the steam will hits the turbine, and the turbine will get rotated. Whenever the mechanical input is given to the generator, it will converts into an electrical energy. So by this you can use the solar energy. Let us go for the next slide. So there are different variants you can use your solar energy. So environmental effects of the solar energy: one is carbon emission, renewable energy, abundant components, cadmium, and space considerations. Let us see about solar thermal energy. You know all, I have already told you about solar thermal technologies. So which involves the harvesting energy from the sun for heating water or producing electrical power. So the solar collectors are used this purpose three types. One is flat plate collectors, another one is evacuated tube collectors, another one is integral collector storage system. There are three types. One is flat plate collectors, evacuated tube collectors, another one is integrated collector storage systems. This is about solar thermal. We can see these flat plate collectors. So from there is an water outlet in these flat plate collectors. There will be a water inlet and outlet. So the water will be heated and come outside through the tank. Okay, so there will be housing, tubing, insulation, absorber, so which absorbs the heat, and there is a solar glass. Okay, like this the flat plate collectors will collect the heat, and the water will be get heated and send it to the hot storage tank. So this is about flat plate collectors. So you can see the evacuated tube collectors. So here there is an cold water inlet and there is an hot water outlet. So in the previous slide there is only a water outlet, okay, there is no water inlet. So there is a tubing here, so from the tubing the water will be came inside, and from the output the water will come outside, okay. And here you can see evacuated tube collectors. There are cold water in and hot water out, and there are tubelets here, heat pipings, and observes this plate, and there is an evacuated tube, heat pipe, absorber plate, and the solar radiation. So whenever this solar radiation hits these plates, so inside the plate will absorb the heat, and it will heat the water, the cold water will be heated and come outside with hot water. So like this evacuated tube collectors are used for the solar thermal energy, okay. Next one is egg-rail collector system. You can see here there are heat absorbing large diameter copper tubes and heat absorbing backplate, the form aluminum and sealed heat enclosure, glazing sheet, and the solar radiation. So here you can see the hot water will come to the home, and city water in, and the hot water will come outside, you can use for your home, okay. So these are egg-roll collector system. So whenever the city water come inside the solar panels, so these plates will absorb the heat, and the water will be get heated and it will be entered into your home. So this is heat absorbing black plate and the solar radiation and form aluminum, sealed water heat. These are the parts of the egg-rail collector system. Let us go for the next slide. So what are the water heating? So one is a passive system. So in passive system you can see thermosiphon and collector storage system, and active system there is a direct circulation system and indirect circulation system and the hot air systems, okay. So these are the cold H2O, so the water inlet, so from through water inlet the cold water will enter into these solar panels, and by the tubelets inside the solar panel, I mean to say solar mirror. So from the outside of the solar the tubelets will come outside and will produce a warm water. So the water will be heated like this by using thermosiphon. So here you can see the passive solar heating and active solar heating. Here you can see this collector panel. From the collector panel the cold water will get inside and the hot water will come on outside. So here you can see with the blue marking will enter to the blue marking represents the cold water and hot water represents the red water. So the cold water will come inside and the hot water will come outside. So like this passive solar heating will be used for your home purpose. And there is an active solar water heating system. The cold water will enter into these circulating pumps. From these circulating pumps the collector will collect this water, and the water will be heated and it will be sent into the hot water tank. So there is an hot water tank, the thermostat control. These are the some heating systems by using the passive solar water heating and active solar water heating. So by using this you can heat your water. And what is the space heating here? So in space heating again you have active solar heating system and passive solar system. Passive solar heating system. So a system that uses water or air, the sun has heated and this then circulated by a fan or pump. The water will be circulated through pump in order to heat your water. And next one is a passive solar heating system. So the house itself acts as a solar collector and a storage facility. No pumps or fans are used. This system makes use of materials of the house to store the and absorb the heat. Okay, you can here you can see this collector. Through collector it will pump the water will pump through the storage and it will be distributed and into the living space. Okay, and there is a space cooling here. So the heat from a solar collector can also be used to cool a building by using the solar heat as an energy source. So you can you can use it for also heat your building also. Okay, so in order to heat your building you can use this solar panel also. So if you go for other shades, there is a very cold temperature. In order to heat the temperature of your home, you can use these solar panels also. So here you can see this solar collecting pump. The cold water will be feeded into the solar panel, and the water feeded water will be entered into the solar panel and come and the water will come outside through the outlet by the solar collector and enter into the tank by using the boiler. So the hot water will be heated. So you can heat your home also. Okay, so by use it to cool your building also by using the solar heat as an energy source. Okay, this is about space cooling. So next one is passive solar heating system. There are three types. One is direct gain, another one is indirect gain, another one is attached greenhouse. So here you can see a direct gain system. You can direct gain system. So there is an concentrate for in winter, in winter, summer and overhanger there is an insulation. So there is an direct gain and indirect gain and attached gain. So here you can see the direct gain house. So there is an concentrate floor, insulation, and you have to give the insulation for like that, and you can heat your home like that. Okay, and there is an indirect, the warm and cool, and there is an insulation, rigid insulation, and water drums and living space. And the greenhouse, you can see that there is an hot air out and cool air in. So cool air in and hot air in, double glazing and black absorber plate is there, and storm form. Okay, and there is a styrofoam. So like this you can heat your home also. And next one is concentrated solar. So concentrated solar is a power generation technology that uses mirrors or lenses to concentrate the sun rays and the heat a fluid and produce the steam. So this steam drives a turbine and generates a power in the same way as conventional power plants. As I have told you in the previous way, so most of these concentrated in the previous flat plate collectors are used to heat. These flat plate collectors are used for your home purpose, like heating water, like heating your home, like that. We will use these flat plate collectors for solar thermal energy. By using the solar thermal energy, you can, by using these liquid flat plate collectors, you can use for your domestic purpose. But by using concentrated solar power, you can generate your own electrical energy and you can use it for your home also. So it is a power generation technology that uses mirrors, so or lenses, to concentrate the sun rays and that heat a fluid and produces a steam. So this steam drives a turbine and generates power in the same way as conventional power plants. So other concepts as being explored, and not all the future CSP plants will necessarily use a steam cycle. Okay, next slide. So the solar power is concentrated in various ways. So what are those various ways? So there are different ways in order to concentrate the solar power. So there are now several devices and structures created which focus and concentrate on solar power. So you can see here in the previous session also I have told you there are solar parabolic troughs, Stirling dish, solar power tower, and the linear Fresnel reflector. So let us see about solar parabolic troughs. So here you can see different pictures of solar power parabolic troughs, Stirling dish, solar power tower, linear Fresnel reflector. Like this we have different pictures. You can see the different pictures. Okay, so these are about concentrated power and liquid flat plate collectors. So by using solar thermal energy, you can generate you can generate your electrical energy by using two sources. One is mainly liquid flat plate collectors, another one is concentric collectors. So these are about solar thermal energy. So let us see what are the uses of solar energy. Heaters, cars, lights, satellites, dryers, calculators, greenhouse, water pumps, desalination, chilling, solar ponds, thermal. So for the commercial use, an office building roof areas can be covered with solar panels. Remote buildings such as schools, communities can make use of solar energy. So in developing countries, the solar panels are very much useful. Even on highways, for every 5 kilometers solar telephones are used. Okay, thank you all. We will meet in the next session.
Solar thermal. The term solar thermal is used to describe a group of technologies that capture the heat energy from the sun and use it for various forms of heating and the production of electricity. For heating, solar thermal systems are referred to as passive or active. Passive systems are more basic and have no moving parts. They simply rely on design features to enhance our ability to capture and use the sun's rays, like a greenhouse or a solar oven. Active systems have mechanical components like fans or pumps to circulate heat-carrying fluids. These systems can be used for residential or commercial heating. For electricity production, high-temperature solar thermal systems called concentrated solar power, or CSP, use groups of mirrors to concentrate solar energy on a central collector. This produces temperatures high enough to generate steam, which then turns a turbine, driving a generator to produce electricity. CSPs are primarily found in desert locations where space and sunlight are abundant. One advantage of solar thermal energy production is that it is a clean and renewable energy source that uses a free form of fuel, the sun. Most solar thermal systems are also low maintenance because they use simple technologies and in the case of passive systems have no moving parts. However, the nature of sunlight can cause problems for the use of solar thermal systems. Sunshine is not a very concentrated energy source, so it can take a large area to make a reasonable amount of energy, evoking efficiency and in some cases land use concerns. Sunshine is also intermittent, and its availability is dependent on location and time. CSP has additional advantages and disadvantages. The technology's ability to produce large-scale generation is an advantage for regions that utilize centralized electricity distribution systems. In the past, this was an advantage over solar PV systems. However, innovations in PV technology are challenging this notion. A key disadvantage to CSP is that installations are normally located in remote desert areas. Given that steam turbines are required to produce electricity, water access and evaporation are concerns for the viability of the technology. In addition, transmission of electricity over long distances is expensive and can lead to distribution losses. Finally, practical challenges such as upfront capital costs and awareness can also be barriers to implementation of all forms of solar thermal technologies. That's solar thermal.
Concentrated solar power uses thousands of mirrors to reflect and concentrate sunlight onto a central point to generate heat, which in turn is used to generate electricity. More than 10,000 tracking mirrors called heliostats reside in a 4 square mile field where they reflect and concentrate sunlight onto a large heat exchanger called a receiver that sits on top of a 550-foot tower. Within the receiver, fluid flows through the piping that forms the external walls. This fluid absorbs the heat from the concentrated sunlight. In this technology, the fluid utilized is molten salt, which is heated from 500 to over 1,000 degrees Fahrenheit. Molten salt is an ideal heat capture medium because it maintains a wider operating temperature range in liquid state, allowing the system to operate at low pressure for superior and safe energy capture and storage. After passing through the receiver, the molten salt then flows down the piping inside the tower and then to a thermal storage tank where the energy is stored as high temperature molten salt until electricity is needed. This technology leverages liquid molten salt as both the energy collection and the storage mechanism, which allows it to separate energy collection from electricity generation. When electricity is required by the utility day or night, the high temperature molten salt flows into the steam generator as water is piped in from the water storage tank to generate the steam. Once the hot salt is used to create steam, the cool molten salt is then piped back into the cold salt storage tank where it will then flow back up the receiver to be reheated as the process continues. After the steam is used to drive the steam turbine, it is condensed back to water and returned to the water holding tank where it will flow back into the steam generator when needed. The result is a high-quality, superheated steam to drive the standard steam turbine at maximum efficiency to generate reliable, non-intermittent electricity during peak demand hours. The steam generation process is identical to the process used in conventional gas, coal, or nuclear power plants, except that it is 100% renewable with zero harmful emissions or waste. These plants provide on-demand, reliable electricity from a renewable source, the sun, even after dark.